Hey, looks like I'm live. Sorry, it's been a couple days. I let my wife borrow my camera, and I was too lazy to hook it back up again. But we're back. So, looks like, oh, I should say, I have been doing the problems every day. I just haven't been streaming them, so I'm still up to date. Everything's good, except for this problem. So, this problem looks tough. We write the integers of arrays A and B in the order they are given on two separate horizontal lines. Now we can draw connecting lines when two numbers match. The line we draw does not intersect any other connecting non-horizontal lines. Note that a connecting line cannot intersect even at the endpoints. Each number can only belong to one connecting line. Okay. Return the maximum number of connecting lines we can draw. So in this example, we have an array 1, 4, 2 and one that's 1, 2, 4. So we see that we can connect the 1 and the 1 and the 4 and the 4 without them crossing. So the answer is 2. So this is a really simple example, but we don't have any other examples. We can imagine if the 4 was before that, then the answer would be 1 because we can't go back past a line that we've already drawn. So what does that mean? Let's look at some samples. So if we had like, oh, we got a hint. Hey, hey, great. Think dynamic programming. Given an Oracle DP Oracle. I don't know what that means. That tells us how many lines A at I and B at J. The sequence. What? Given an Oracle DP, which usually means some sort of data structure that I'm using the cached results of the dynamic program. Given two numbers, I and J, they tell us how many lines A at I and B at J. The sequence A at I plus 1, dot, 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 and B at J plus 1 are uncrossed. Can we write this as a recursion? What? Okay, I don't know what the heck that means. I guess what they're saying is that if we consider a data structure where you give it an I and a J, and we keep track of every number from there on, every combination from there on for that spot. So if we thought of it that way, and we got a 1, 4, 2, and whatever this was, B, 1, 2, 4. So our data structure, DP at 0, 0 is how many lines for A and B, the sequence A and I, and so on. This sentence is driving me nuts. Are uncrossed. So maybe it's easier to start at the end. So DP at 2, 2. There's no lines. There's no way to connect 4 to 2. So what about 2, 1? There's one line that could be made between the 2 and the 2. Okay. What if we looked at 1, 1? We would cross here. So the maximum that we would do is 1. Okay. Trying to figure out how I know that. And if I do see one that would be... Okay, we're doing dynamic, so basically I would... If I cross through this line, I have to be better than that. I don't know. I hate this. jeez. Give an oracle DP that tells us how many lines between the two, the sequence are uncrossed. Uncrossed. What do they mean by uncrossed? Do not intersect any other connecting non-horizontal lines. Let's try counting up and see how that goes. I'm just struggling, so if you have any ideas, hey, how's it going? Yep, I'm back. And what a crappy day to come back on. I don't know what to do with this problem. Have you done it yet? So if I'm looking at 0, 0, then I see that the numbers are the same. Then the answer is 1. Okay. Yeah, this definitely don't peak. I'll hide that. It looks like a fun one, and the month is almost over, so I'm hoping that the rest of them get easy. The last couple days have been good, though. But today, I don't know. This is my weakness. But that's what I'm here for. Oh, cool. Hey. All right. Well, hopefully I'll get this one wrapped up, and I'll pop over to your stream. Y'all, if you're here, you gotta check out Y'all Coding. Also, let me fix the comments. So I still have not done any of that. Chat box properties. All right, hopefully that starts working now. Yep. So we look at A at I plus 1, A at I plus 1, B and J plus 1. Okay, so if we compared every number straight up, then we'd have one line there. Yeah, I am suffering. Think dynamic programming, giving an oracle DP. Whoa, really? Jeopardy-like game? Like trivia? That sounds like fun. Oh yeah, totally. That sounds like a lot of fun. Do you remember the name of it? Sequence. Yeah, we could use a new game show. It's been a while. Play Factile. Huh. That's cool. All right. I'm just gonna try one now. One team, sure. No. Oh, team captain. Definitely broccoli. Okay. Okay, awesome. All right, I'll check that out. Oh gosh, world geography. I'll take continents for 100. Whoa. Asia. Yay. All right. All right, I'm gonna try continents for 500. Let's see. Africa. All right, I'm doing awesome. This is much easier than I expected. All right, I'll do one more. We'll try nations for 500. Two rivers that are borders of the United States. That are borders. Oh gosh. I know the one down here is. Oh god, I want to say the Colorado River. It's very loud. Ooh. I don't know how to make that quieter. I don't know what the other one is. St. Lawrence and the Rio Grande. Okay, wow. So I don't know anything. Oops. I failed there. Very cool. Yeah, I'll give that a shot. Thank you. Oracle. I'm curious if that's like a standard term. DP programming. When I hear the word Oracle, I think about like predicting, prophesizing. And this is all about Oracle database. Okay. It tells us how many lines. How many lines? The sequence of A plus 1, A and I plus 1, and BJ. Oh, BJ plus 1. Okay. Yeah, let's try. This is way too loud. Jeopardy blew my ears out. All right. So we do have a ... here. So I'm not quite sure how to interpret this hint. How many lines at I, J, the sequence? So at DP00, they're going to store the results of the sequence. How many lines are in the sequence? A at I plus 1, and B and J, J plus 1. So you're going to be how many lines? So obviously we got one line there. And we go through. I'm trying to avoid basically comparing every number against every other number. So here it's easy to see we're at I and J equal to 0. And we do have a line. So I know that this is going to be at least 1. But I don't understand what to increment now. So if I increment I and leave J, then that's weird. I mean, I do see a match, so maybe I increment both. Now we don't have a match, so which one do I increment? They're not sorted, so it doesn't matter. So I will choose to increment this one. And they do match, so we change you to 2. And then we increment both of you. Okay, you've exceeded the bounds, so we're done. But here, what do we do? Is it 1 and 1 or is it 1 and 0? Oh, jeez. Okay, let's just say it's 1 and 0. So, does not match. So we move on. Does not match. So when it did not match here, which one should we have incremented? So if we exceed the boundary, then we're missing these matches. So I guess I should increment the lesser of the two if they're not equal. But then, yeah, this doesn't work very well. So we got 4 and 2 comparing. Now which one do I move? If I move here, we're good. If I move there, we're good. Either way, we're going to get an answer of what? We started here, so we get an answer of 1. I hate that. That's not right. You know, we're only looking at 500 and 500. Maybe I'm thinking too hard about this. So n squared would only be 2,500 comparisons. Is that right? 250,000 comparisons. My bad. Quite a bit different. So, I don't know. Maybe I'll just write it that way anyway. Let's take it over here and just see how long it takes to brute force it. Yeah, maybe brute forcing will help me anyway, because I'm not really clear on how to detect if there's a line or not, or if there's a cross, I should say. So maybe that'll help me kind of reason that out. Call this one crossing lines. All right. What am I doing? I need to do for each index. Oh, sorry. There we go. For each index. And which one's first? This is the index, and this is the value. Oh, that's the problem. This is a lambda. All right, for each element in A, we're going to look at each element in B. And if A equals B, what does this even tell me? If I'm looking at a 142 and 124, so I'll look here and here. I can see that I do draw a line. Equals plus was the return count. So I'm missing a very important part here. So I've got 1 and 1 equal, which means that I need to not look at 1 again. So this for each isn't really great. Let's just do it old school. All right, old school. There we go. There we go. All right, back to parity. So I don't have any increments going on. But if I see that these two values match, then we'll bump everyone up. Else, who do we bump? Ah, jeez. Maybe brute force is not going to work very well. Yeah, I hate this problem. So if I didn't have that clue, I would be thinking about dynamic programming. Same length. Okay. One, 4, 2, 1, 2, 4. So when I see two match, I almost feel like I need to go through, loop through both. And if they match, then I have a data structure. Call it dp equals hash map of tuple of int to an int. A pair of ints point to int. Okay. And we say if dp, okay, I like how that's going. So we'll loop through each of these in an n-squared fashion. No, not good enough, but we'll think about something. So we'll compare these two one to one, and either my choice is either we consider those connected, or we think that there's going to be a better connection later on that's going to free us up to have more lines. So my DP will keep track of what's better, if I left them connected or not. So I almost want to say, let's bring all that stuff back I deleted. I is less than a dot size. Okay, and while j is less than b dot size. Okay. So, if this will compare every number against every other number. If, well, file a equals a, it's sub I, so that way I don't have to keep indexing things. Oh my gosh, what do I do in here now? So if a equals b, then either this is an optimal connection, meaning we should keep it, or it's not. So what I'm kind of thinking here is basically we need to figure out whether it's more beneficial to cache this one equals see, how do I find out if it's an optimal connection or not? Alright, how long have I been streaming? I might have to go cheat here. We're at 25 minutes. I don't even feel close. I'm gonna look for some help on this one. Let's cheat. So I'm not even sure how to really think about this problem. I am struggling with it. Let's see. See if there's some discussion about it. That hopefully doesn't give the whole answer away. I just like a hint that I can understand a little bit better. One summary. Longest common subsequence. Well, that's interesting that they call it the longest subsequence, and I guess you can consider it that way. So the longest common subsequence is something similar to what we did with the Cadane problem. Huh. So if we thought about this as the longest subsequence, but in this case, the only items we count are the ones that match. How would I solve this problem if it was longest common subsequence? If I wanted to know the longest common subsequence between these two, I would start at 0 and 0. If they would match, I would be greedy about it and count 1. Yeah, what about this? Return max. So we start out max at 0. All right, and then we have a var I equals 0 and a var j equals 0. And we have a count for the items starting with this index. Oh gosh, I just don't know that this is going to work. Alright, let's just think through it. So we'll go through all of these and compare it to every one. If the items match, we'll increase j and I. If they don't match, our last match equals 0. RJ equals last match. Okay. So we'll keep count per iteration of A. We'll keep track of the last match index for J. We'll start out at 0. So while it's less than, we'll iterate. B is equal to B at J, not at I. Okay. If A equals B, then no DP. Then our count goes up. Our last match index equals J. I goes up by 1. J goes up by 1. Else, J goes up by 1. Okay, there's our last match index. So we'll keep track of the last one we matched, and we come back around and we set J equal to that. So why are you yelling at me? J is assigned to var last match. It's never used. The value J assigned to whatever is never used. C's right there. Oh, this should not be here. So we started at 0. Yeah, what do I care about that? This is a bad algorithm. This doesn't work. All right, I'm just gonna need to look for another hint. Simple DP, sure. Oh my gosh, I hate how simple this is. So DP equals, so here, 0 for blah. They're initializing a matrix. Then they loop through 1 to length a plus 1, interesting, okay. Same with B, and then they say that DP at I and J is equal to whatever's bigger. The previous result, they're starting at 1, so that's okay. Oh, okay. So this is similar to other DP problems that I've really done poorly at. So it's basically either equal to the previous result of the I row or the previous result of the J row. Okay. And if they're equal, then we set the result equal to whatever's bigger. The answer right before us, +1, or whatever answer we already have there. Okay. So, let me think about this one. How do I kind of internalize this? So I've got a hash map. I'll call it DP equals hash map of, and I'll just do a string, not a pair. String and an int. Okay. I could have done arrays here. I know the size. Would I rather do that? Yeah. So let's have an array of arrays. An array of pairs. No. An array of int arrays. The size is equal to a.size. Okay. Now we need to fill this sucker in. Hey, what's the problem here? No value passed for parameter init. Oops, okay. Oh no, it needs to be an int array. Dot size. oops, sorry, b dot size. Okay, an int array is automatically initialized to 0. So now we are going to loop. So we need my I and j back. So while, while I is less than a dot size and j is less than b dot size, what are we doing here? dp at I at j equals whatever is bigger. Whatever is bigger. Between I need this array to be a little bit bigger. I think I need it to be, because I have to count for the 0th. Like I'm doing this weird caching thing. I need to be able to reach back. Okay. So less than or equal to, less than or equal to. So this item is equal to whatever's bigger. And in the first square, it'll always be 0. So the way this basically represents what does that represent? I don't know what that represents yet. All right. If so this will set our initial value. If a at I minus 1, so remember we're reaching back, is equal to b minus 1. Then we have a special case here where we might need to override this and say, hey, you're either equal to something or your current value. And this something is going to be our previous result okay, and at the end of all this, we return dp dot last dot last. So I coded what they did. It's still really foggy for me to try and explain what's going on here. I mean, obviously you can see that we're caching whatever's biggest. Our top row 0, our top row index, or our bottom row 0. So it's kind of like saying keep the best result. Initialize this to the best result we've seen so far. And if they happen to be equal, then let's go ahead and add this so it's either adding, oh, I need to add one here. I'm missing something. Either need to add this or keep it as it was. Whew. So, what on earth? I'm gonna have to look at this again. For dp equals length of b plus 1, got that. Length of a plus 1. So they did b on the outside. I don't think that matters. Now they're gonna loop from 1 to the length plus 1, which I got with the greater than equal j as well. They're equal to the max of either the one up left of me or less than 1. Okay, I think I got that right. I1 and j, yep. Now, if they are equal, the previous one, then this item equals the previous item plus 1 or that one. So I think I did it exactly like they said. What? Okay, let's try that again. Have an infinite loop. I return 0. So if this equals each other, then we should always either get either. In this case, it would be 0 plus 1 or 0. So, I mean, the only thing I did differently was I had those backwards. That's not going to matter. I is less than. Okay. Alright, let's take this into IntelliJ. And input looks like that. All right. Then 1, 2, 4. All right. Crossed lines. Solution. A and B. And we should be able to assert equals 2 and result. Let's see. This is not happening. Maybe we'll be able to see what went wrong. My breakpoint didn't get hit there. Let's try that again. I think it did on the lambda. So DP equals the data structure. It's got size of 4 and size of 4. Initialize to 0, so that's all good. Alright, now while I, which is equal to 1, is less than or equal to a.size, which is 3. Okay. What? Oh, I got greater than. What the heck? Okay. Let's try that again. Now it's going to give the right result. Why is that taking so long? I'm not incrementing I or J. Let's try that again. Again, I gave the wrong result. What happened? Okay. DP and I and J equals whatever's bigger, 0, 0. Now these do equal. So I set either the max of. Okay, so now I should have a 1 in here. At this position, and I do. Okay, and so when I come back around now, this is that J1. So now I set it equal to dp at 1. So here, this should have gotten set to J at 2. We're at 1 and 2, so position 1, position 2. Should have got 1, yep. Oh, that's not position 2. That's position 2, which is also 1, so that's good. Okay. Okay, so now we're setting our position at 1 and 2, which should already be set to 1. 1 and 2 is set to 1. Either equal to 1 minus 1 minus 1, which is 1 plus 1, so 2, or 1. So that should get set to 2. So if I go back and look at dp at I and j, it didn't happen. So let's evaluate what went wrong here. So here I got a result of 1, and I think that this should have been 2. Okay. What did I do wrong? I minus 1, j minus 1, a minus 1 equals. Both times we're doing that. So we did come into here. We're looking at index 1 and 2. One and 2. So your previous was I is a 0 and 1, which was set to 0. Alright, while I is less than A, J is less than B, dp I and J equals max I minus 1 and J, I and J minus 1. I minus 1 and J, I and J minus 1, A minus 1, and B minus, oh geez. Oh my gosh. Alright, so again, wrong answer somehow. A minus 1 is equal to B. At this point I'm just porting this answer to Kotlin, and I'm doing a poor job of that even. So, happy Memorial Day. Max I minus 1 and J, I and J minus 1. Okay. Okay. Yep. I minus 1, J minus 1 plus 1. Yep. I and J, yep. I wonder if it didn't compile. Let's take a look and see if we screwed up this last part. So how did this line die out? Ugh. So this is the first time we're incrementing, and we're saying 1, 1 should get to be 1. So we'll set this to 1. Whoa. And then we never hit this again. Did I not increment my values correctly? For I and for j in. What the heck? So somehow I should be looking at every possible combination, so I should have hit this more than once. So this is when I and j are 0, so we're looking at 1 and 1 here. And somehow we never get to the 4 and 4. How is that even possible? I'm just looking at I and j, 1 and 1. 1 and 2. So we're looking at the 1 and the 2. That's fine. Okay, the 1 and the 3. Oh, I never set j over again. Jeez. Okay. This is the problem. Index out of bounds? No way. J shouldn't equal 0, it should equal 1. Now it's gonna work. And that's the solution. So this is very similar to a problem that I really struggled with last time. So I need to figure out what the deal is with this kind of class problem and like what it is that I'm missing. So once again, I think I could have sat here for another hour and not gotten to the bottom of this. Ugh, do I have an infinite loop? I hate that phone so much, sorry. Type receiver mismatch, double. Get my import in there. So I keep threatening to go back and look at dynamic problems. I don't feel like doing it today. It's raining, got a headache, ain't doing it. So we did, one thing we could have done better about is we could have had less space. We didn't need to cache all those. We only ever looked back 1, so we could have just kept minimum variables. I don't see where we ended up here. Let's look at the best answer. Wow, yeah, even better, I kept an array, which I think they could have avoided. Yeah, I guess they couldn't have avoided because we do keep going over. So yeah, clearly I need to work on this kind of problem really badly, but not today. I'm going to go check out y'all coding and see how he's doing. Alright, hope you guys have a good one. Hope y'all have a good one. Yeah, let me make sure the bell rang.